The product of powers rule is used when we are finding the product of powers, meaning we are multiplying together powers. This rule can only be used, and this is really important, when the bases are the same. When the bases are the same. So same base here. When the bases are the same, we can use this rule, which is that when you are finding the product of powers, you can add the exponents. It is very common for students to think they have these rules memorized and to know when to add, subtract, and multiply. And then when they're all mixed up or in an assessment situation, to get them confused. If this is something that happens to you, you can go ahead and write the expression, such as 2 to the third times 2 to the fifth, in expanded form. 2 to the third is 2 times 2 times 2. 2 to the fifth is 2 times 2 times 2 times 2 times 2. That is 2 times 2 times 2 times 2 times 2 times 2. That will remind you that 2 to the third times 2 to the fifth is 2 to the eighth. You are adding the exponents, but if you forget that rule, you can go ahead and recreate it for yourself by expanding it. 2 to the eighth is going to be 4 times 4 times 4 times 4. 16 times 16. I think that's 256. You can use a calculator to find the value when you have a numerical base within reason. Here we have 3 times 3 to the fourth. This is a common source of mistake. This invisible exponent is not an exponent of 0, it's an exponent of 1. So if you're using the rule, you need to do 3 to the 1 plus 4, or 3 to the fifth. That's going to be 9 times 9 times 3, 81 times 3, 243, I think. It's okay if we're taking a product of 3 different powers, d to the 6 times d times d squared. I would write d times d times d times d times d times d. This is 1d and d squared. That means I'm going to have an exponent of 6 plus 1 plus 2. That is 9. D to the 6th times d squared is equivalent to d to the 9th. I do not have a value when I have a base that is a variable because I cannot evaluate a variable base unless I'm given a value for that variable. So if your base is a letter, not a number, there is no value possible. Really important to make sure you understand this rule only works when the bases are the same. I can't somehow write this as xy to the 9th. X squared y to the 7th just stays x squared y to the 7th. I can't somehow squish those together. If there's a coefficient in front, that 3 is not in parentheses, so I just have 3 times x to the 4th times x to the 5th. That means my simplified expression is 3 times x to the 4 plus 5, x to the 9th. Same thing here, even though I have a numerical base, the 4 is separate. 4 times 2 squared times 2 to the 3rd, 2 plus 3 is 5. It's okay if the coefficient is on one of the factors in the middle. I still move it to the front, just keep it as -2. R to the 3rd times R to the 8th times R squared is R to the 3 plus 8 plus 2, which is 3 plus, it's 11 plus 2 is 13. -2 times R to the 13th. I mean, that is equivalent to R to the 13th times -2, but that is not very pretty. Coefficient number goes in the front. If I have more than one coefficient, I just multiply them. 2 times 5 is 10. W squared times W to the 5th, I just add those exponents. That's W times W times W times W times W times W times W. Here, -7 times -9. Pay attention to your negatives. Same base, I can add. Coefficients, 6 times -8. Again, pay attention to negatives, but s to the 3rd, t to the 8th, those cannot be simplified any further. Different bases, s and t. This simplifies just to -48, s to the 3rd, t to the 8th.